Structural change. So I think we're basically going to finish this today, because it's basically just two models that I've gone through on the videos, and we've already talked in general terms as well. So the big question is, if consumers, so Solo said if the stuff's running out, consumers can switch to products that need less metals, energy, whatever. But to explain this, it's the opposite that's been going on, isn't it? The stuff sort of isn't running out. The price has stayed constant for the resource input, and consumers have switched, for some reason, to more and more resource-intensive goods, which has cancelled out the effect of increasing resource efficiency in each good. So why have they done that? And that is super relevant for policy. And what are the two potential explanations that we talked about, I'm sure, last week? Two effects. Anyone? Looks like you've got something.
Substitution.
Yeah. Can someone else help us? What's that about? Substitution. Is that right? Something like that. Someone else? What's that about? Have you got something there?
What the substitution effect is about.
Yeah.
That you would trade one good for the other.
Right. But why?
Because they would fulfill a similar function.
Yeah, it's basically to do with prices, okay. That if one gets cheaper, or we like cheap stuff, we don't really care which of these we have. One of them got a bit cheaper, we'll switch. That's basically what substitution effects are about, relative prices. And what's the other effect?
Income.
That's the income effect. So what's the story behind that one? If this is about relative prices, what's this about?
Relative income.
Not so much relative income. Well, I guess over time. But so if I've rubbed it off now, but if we're trying to explain this data and so on, what would the income effect be? We got richer, and if there's a strong income effect, it's like rich people like this energy intensive. If we stick with energy, rich people seem to like energy intensive stuff, right? So as we get richer, we switch systematically to more energy intensive types of stuff. That would be the income effect. Okay. Because remember, the whole point is that growth isn't just, the doubling of GDP isn't just twice as much of all the same stuff, we're changing what we buy. So what kind of, and it seems like we change towards more energy intensive stuff. Like more transport compared to other things, more lighting compared to other things. And within transport, we shift modes of transport from trains and buses to cars to planes, for instance. And within cars, we shift to bigger and bigger and more powerful cars, etc. What is driving that? So if it's a substitution effect, what do we have to say about the change in relative prices over time? If there's a big substitution effect going on towards energy intensive stuff, what must be happening to relative prices?
It needs to decrease, so the more energy intensive stuff gets cheaper.
Right.
Cheaper.
So if there's going to be any hope for this to be a good explanation, we would need to see in the data that energy intensive stuff gets cheaper relative to other stuff. Okay. I'm not sure I've got any really good data on that. But is there any reason to suppose that might be the case? Well, there is actually. So, what happens to the price of labor over time?
Increases.
Right? More specifically?
Tracks GDP.
Typically more or less tracks GDP, right? Especially if we think of sort of labor capital bundled together, then it definitely tracks GDP. But what happens to the price of energy over time?
Stays constant.
Right. What happens to labor productivity over time? More specifically? That also tracks GDP,
yeah.
because that's what's driving the whole thing, yeah. What happens to resource or energy? We stick with energy for now. What happens to energy productivity over time?
Same.
Right. Probably tracking GDP or even growing faster than GDP. Remember the lighting? Really. So then imagine a good which is using a lot of labor. It's mainly just labor as the input. And then imagine a good which is mainly using a resource. What's going to happen to the relative prices? Of the goods. So if we have Y1 is AL, L1. So we've only got labor. And then we've got some other good, Y2, which is AR, R2. The only input is the resource. Okay. AL is growing at 3% a year. L is constant, say. WL is growing at 3% a year. So what's going to happen to the price?
The relative price of good 2 will decrease faster than the first good because we use the resources so much more efficient compared to people.
So we could do a quick profit thing, couldn't we? And we could say, well, pi 1 is like P1, if that's the price of this, times AL L1 minus WL L1. Okay. And then we could take the first order condition and we could say that P1 AL equals WL, couldn't we? We take the first order condition in L1. It's just linear, so it just pulls straight out. So we get P1 is WL over AL, which is going to be constant, right? Because the wage will rise at the same rate as labor productivity. But if we do the same thing here, we're going to end up with P2 is like WR over AR. WR is constant and AR is growing, so the price of this one is going to be like nosediving. So it's like a super simple model, but the basic story makes some sense, that if you've got this input, the productivity of which is growing, the price of which is staying constant, the price of goods which use a lot of that input is going to go down, right? So maybe it's all to do with the substitution effect. This energy intensive stuff gets cheaper and cheaper and we all pile it. Or maybe it's an income effect. And if it's an income effect, the story is just that rich people like energy intensive stuff. Rich people prefer to fly than take a car, and they prefer the car it's not so much about the price of the plane ticket. Small changes in the price of the plane ticket, or even fairly large changes, aren't going to make much difference. It's really the income that is the driver. Okay. And we can set up a really simple model, which is pretty much the model that I just was sketching here, where there's potential for massive substitution effects. Because you have one good that is made purely using labor, and another that is made purely using energy. We're going to stick with energy for R. And then, if the price of labor is going up, but not the price of the resource, the price of this good, final good, is going to fall compared to the price of that one. And then we say that consumers have the utility function like this. So what would the indifference curves look like here? So if we can think of y as utility here. Okay. And then we've got y1 and y2. Okay. Have a think about this. What are the indifference curves going to look like? Chat to your neighbour or whatever. I'll come round and talk to you.
Yeah, any idea?
What do indifference curves usually look like?
Or
Yeah.
but like a straight line. Yeah.
Okay. So, say again, if they're perfect substitutes.
Then there's a straight line.
Yeah. And what value of epsilon would we need then?
Then the opportunity.
Actually, I put a stupid minus sign in for some reason.
Minus
So it would be -1, yeah. What about if epsilon was infinity? What would it look like then? Or infinity with the minus sign. Minus infinity without. That's Leontief, isn't it?
Yeah.
Yeah, good. And if it's in between, the curves are going to look like this, aren't they? So the degree of substitutability has to do with the curvature of the indifference curves, basically. And with Cobb-Douglas, you've got sort of some nice curvature, like this. Very roughly, this would be some kind of Cobb-Douglas. And when we raise epsilon, as it's defined here, we're going to increase the curvature here. And that is going to make substitution kind of harder. Because the slope, you're going to need a bigger change in the slope of the tangent to get any given change in the relative quantities. These are almost straight. A small change in the slope will shift you from like here to here. Big change in quantity. But if they're super curved, big change in the slope is hardly going to change the consumer's choice of where to be. Okay. And basically, with this setup, as I think I said in the video, it's pretty much, you've hardly really done anything. Because you've sort of got you've got labor and the resource, and then you combine the goods, and then that goes to the consumers. if you say that this combination is, if we set epsilon equal to 1, sorry, to 0, here, then again, we end up with Cobb-Douglas in the which I'm still not going to go through, called L'Hopital's rule. Then we can write y is y1 to the alpha, y2 to the 1 minus alpha. And it's really, we can just sort of put a black box around everything. And we're back where we started with, aren't we? So not surprisingly, even if we take the black box away and look at the details, it's all going to play out just the same. We're going to have fixed factor shares. Okay. And that's when we have one input, one good that is just uses labour, and one good that just uses the resource, and then we've got a high degree of substitutability between the goods. The elasticity of substitution between them is in Cobb-Douglas. What's the elasticity of substitution between these two? One. Yeah. But if we made a lower elasticity of substitution, make this epsilon here bigger, that is going to kind of reduce the power of this substitution effect. And then we won't any longer be able to match the data with the model. Okay. So this model matches the data, the aggregate data. But what happens when we zoom in from our bird's eye view and start looking at the detail? Are there really goods with almost entirely labour capital as inputs and hardly any resource? What do you think? Are there goods like that? Where we can pretty much say, look, there's hardly any resources really used in this good.
Some products.
Yeah? What kind of products would you think of?
Daycare, maybe, or a service.
Yeah.
Yeah.
There's a bunch of products actually where it's like, wow, you know, you're receiving one of them right now. Okay. Stefan's paying for it, but it's still a good, right? I mean, you might think it's rubbish, but we still call it a good. Okay, so there's a bunch of goods out there where it's like, wow, you know, how much resources are we really using here? It's not zero, but it's like pretty low compared to the sort of 3-4% average. It's, you know, like 0.5% or something. Like you said, all these sort of super labor intensive things, healthcare, daycare, education. It's like labor costs are like a massive part. But are they goods where like 90% or more of the cost of resource inputs, final goods? Because there are intermediate inputs with that, but that's not the point here. We know that. But there's sort of, you know, coal is an intermediate input or whatever, it's basically just the resource. But are there final goods where you can sort of trace it back and say it's basically only been energy used to make it? Yeah, but that's not really a final good. It's kind of messy, but really the fuel is an input into the delivering the transport, which is the final good. But so that's it's tricky. But you want to think about what does the consumer actually get utility from? It's not the fuel as such, that's more the sort of production, the arena of production is sort of shifted to the household. You're producing the transport yourself, having bought the capital good yourself rather than car. But effectively, the good is the transport. So you can think of the car being more here, and the final good being the transport.
Then I can't think of
It's tough, isn't it? Does anyone want to guess, or if you've read the blurb, like what proportion of air travel costs does the fuel account for? Any ideas? I think it's in the book, but it's not like you should have read it.
90% maybe?
No.
Is that way too much?
I think I've heard it before, but I think it's around 20%.
20?
Yeah, it's round about 20%. The cost is going to vary depending on a bunch of things. You know, how efficient the aircraft is and what the degree of service is and how far. It'll be different for long haul flights to short haul and so on. But round about 20%. So what are the other costs? Janina, what's the other 80%? Or anyone, I'm not trying to put you on the spot. I'm just,
Different type of labor and like gate placement maybe?
the gate, yeah, so there's a hell of a lot of people, if you go to the airport, there's a lot of people buzzing around, aren't there? So that's one thing, all the labour force at the airport. But what else?
Taxes and stuff.
Yeah, no, they don't really count here.
Okay.
So this would be 20% of the actual costs, not including taxes. So the actual planes, right? They're not cheap, are they? And it's not like your old banger that you sort of take for a service every couple of years, or it's like they need constant maintenance, don't they, for safety. And then of course there's the cabin crew and pilots, but I'm sure the capital costs, and then you've got to maintain the runways and so on. I'm not an expert, but there's plenty of places for costs to mount up. And of course, planes aren't that fuel guzzling. The big problem with planes is not really how much fuel they use per passenger kilometre. It's not that different from driving I can't remember, I've looked at this data, but it's a bit too long ago. It's not that different from one person in a car per kilometre. What's the big difference?
How far we go?
You get so bloody far, don't you? It's like, we're not about to drive off to Thailand. So if you think about it per minute, then there's a big difference. Because you're doing 10, 15 times the number of kilometres per minute. So then you're going to have, per minute, it's going to be 15 times the emission. And then you've got, if you're worried about climate, you've got double, more or less double, because of the contrails and so on, and the effect of those. Do you know contrails? It's like the cloud, the tracks behind the plane. Okay. So this is a massive problem for the idea that this kind of mechanism might be very powerful. Okay. Because if this good is 100% labour, let's think of a simple model, make this one 100% labour, and this one 20% resource and 80% labour. And then to get the 5% resource in total, we'd be saying that there's sort of 3 parts this one to 1 part that one, wouldn't it be, I think? Yeah, I think. So a quarter of the economy is this resource-intensive good, which is 20% resource. And 3/4 is this very low resource sector. Okay. If you built a model like that, and then said there's Cobb Douglas between the two products, how big an effect are you going to get if you assume as well that AR and AL track each other, and that WL tracks AL, and that WR is constant? So with those assumptions and the original model, we could deliver this result. Okay? But if we now say we've got a labour-intensive sector which is 3/4 of the economy and a resource-intensive sector that is 1/4, but in the resource-intensive sector it's 20% R, 80% L by factor costs, factor shares. But we stay with this, and we stay with this. How is this going to look? Have a think. I'm going to give you a few minutes to think about that. If you can get your heads around that, you're doing absolutely brilliant. Well, you're doing brilliantly anyway. This is mine, isn't it?
Any thoughts?
Me too. Are we talking,
So why two is not entirely made of resources now?
yeah,
Okay.
yes.
They should all go less.
So he wants us to like, we should assume what he just said about
Yeah.
AR and AO.
I think the question is what will happen to R.
Yeah.
By
By
assuming that
assuming
must
it's
increase
close.
super much because it's cheaper, and if it's substitutable.
Doesn't But- it's cheaper though if you said they use less of it.
No,
It's not inherent that it's cheaper.
I'm just thinking like in the long term, if it's that, what is it, WL, yeah, like that, it tracks Y, while WR stays constant, like after some time, it feels like you would like to substitute more and more L for R. That's my,
But that's what we had in the beginning. Or like I guess what
Okay.
changed now is that we can substitute away L from the R.
we could,
We need to have, because we don't have any goods that are entirely made of R.
but he said we should assume this called Douglas.
Or I interpreted that that was like the change that we would
Uh-huh.
or
Okay.
I'll see like what we said before, like if we have two goods, one is on the L and one is on the R, then it will fit the data. But what if the R good is 80% labor, then what would happen to R? Wasn't that the question? Or that's how I interpret the question.
Could be right. I don't know. Okay, so if that's the case, then what will happen?
So we've only had one break, haven't we?
Yeah.
Yeah.
Do you need another break?
I guess it's a bit late.
It's
Yeah.
fine.
Let's just go on with it. Right?
Or should we just take a technic pause, let's say? Take a like 3-minute break, just stretch your legs.
Yeah.
Yeah, let's do that. So normally I say like never less than 7 minutes, it just doesn't work. But if we can just do like leg stretch, technical. Sorry, I missed the whole load of video time. So it's a lot more subtle, the math for this model. So don't get too hung up on this. So is there any rebound in this economy? the effect of taxing energy use be? So is there any rebound? So is there any substitution effect? That's an easier question.
No, it's the same.
There's no substitution effect whatsoever. Yeah. So consumers will just, they have this what we call lexicographic preferences. They will choose the best good they can afford. But there may be some very, very slight rebound, which is that if you raise energy efficiency, it could be that if you have a spread of consumers, some of them, that might tip them over to being able to afford the next good up, because the prices will go down. But as long as the energy share is only about 5%, then that effect is going to be very small. Okay. Because effectively, if prices go down, the value of your income has gone up. So it is effective, it's an income effect of the price change. It's not a substitution effect. But that small income effect will give you a very small amount of rebound. So technically, it's a small amount of rebound, but it's nothing we need to worry about. So it basically means that the more energy efficiency, the better in terms of bringing R down. What the nightmare is, if labour efficiency increases in the energy intensive sectors. That's like the worst case. That's not really in the model, because this is just, it increases equally into both sectors. We take it outside. But imagine if this efficiency of labour in the top sectors increases a lot without this increasing. So it's like, imagine if airports get way more efficient and aeroplanes get a lot cheaper to build. That is going to have a big effect on ticket prices, right? So that is another potential reason that we haven't talked about for why there could still be a role for a substitution effect, actually. That maybe the energy intensive goods got a lot cheaper, not because fuel got cheaper, but because we cut labour costs in those sectors. I should probably not have said that, because it's kind of it's getting too complicated. Don't worry about that. The main story I want you to understand is why it's tricky for substitution effects to explain this data. Whereas on the surface there's more potential for income effects to explain it. And if it's all about income effects, then we don't have to worry too much about rebound. But things like taxes on fuel are not going to have much effect. At least not via the structural change channel. And then we kind of said they're not going to have much effect either through the energy efficiency channel, because there's just not that much potential for increased energy efficiency. So which channel might they have an effect through? Not structural change, not energy efficiency. It's just a revision of what we said about 10 minutes ago. I can't remember who said it. I think it was you, Janina. If we want to get emissions from the air travel sector down.
Just switch out of the source.
Right. So you think of the Solos mechanisms, yeah?
If I
not the structural change mechanism, it's not the energy efficiency mechanism, it's the switch resource mechanism. So why would firms switch resource if you taxed fossil fuels? When you put the question that way, it's pretty obvious, isn't it? Could be that with the firms are adding the tax to the fuel, they, in their calculations, and at some point it might be shit, it's actually worthwhile trying to develop whatever it might be, battery technology for planes or catapults. Don't think that's going to work, is it? Okay, time to finish. Any questions before I will disappear? So that's structural change, and it's Friday, isn't it? The last lecture we're going to look at pollution, and that is the big focus with pollution is on. Oh, it's gone now. But the third mechanism, the shift in choice of resource input, and why we see that happening in the case of pollution. That's quite a neat model. Okay, let's stop there.